of Machine Learning Bootcamp on behalf of Jarvis Forum and Microsoft Learn Student Ambassador. Did you guys enjoy yesterday's bootcamp? Let me know in the chat section or just raise your hands. Am I audible? Okay, I can see 3 plus. Okay, so without waiting further, I request our today's speaker, Jnanish Kajpiye, to proceed further. Over to the speaker. You guys can raise down your hands.
Hello, am I audible? Hello, am I audible? Hello.
Yes, you are audible.
Yes, yes, yes.
So, hello guys, welcome back. So, how are you doing? Can anyone comment? Hello. I'm not able to see comments. Okay. Okay. Good. Good, Weber. Okay, Sri. All good. Okay, so without further ado, let's move forward. So guys, today we are gonna learn actual machine learning. One of the actual machine learning algorithm, that is linear regression. So before we do that, let's get to know what machine learning is. Yesterday, my friend Atharva did told you about machine learning, but I have a little different definition for it. So, what Arthur Samuel said about the machine learning is, it's the field of study that gives computer the ability to learn without being explicitly programmed. Uh, So back in 1950, she wrote a checkers playing program. The amazing thing about the program was that Arthur Samuel himself wasn't a very good checkers player. Okay, Aisha, I'm good. Thank you for asking. So what she did was she had programmed the computer to play maybe tens of thousands of games against itself. By watching which social support position wins and which loses, the checkers playing program lean over time. What was good or bad support position by the trying to get a good and avoid bad positions. This program learned to get better and better by playing checkers it by itself, because the computer had the patience to play tens of thousands of games by itself. It was able to get so much checkers playing experience that eventually it became a better checkers player than Samuel himself. Let's move further and dig deep into the supervised machine learning. Uh, just a second. Yeah. So, supervised machine learning. Uh, just a second. Let me clear this. Yeah. So, supervised machine learning, or more commonly supervised learning, refers to the algorithm that learns X to Y, or input to output mappings. The key characteristics of the supervised learning is that you give your learning algorithm examples to learn. That includes the right answer, where I mean the correct label Y for the given input X is by seeing correct pairs of input X and desired output label Y. That the learning algorithm eventually learns to take just the input alone without the output label, and gives the reasonable accurate prediction or guess of the output. If the input X is an email, let me move. If the input X is the email and the output Y is also the email, so we need to detect whether it's spam or not. This gives us your spam filter. So it's basically these are the applications of supervised learning, like spam filtering, speech recognition, machine learning, online advertising, and self-driven cars. So if uh, if our input is English and have to have the output corresponding to Spanish, Arabic, Hindi, Chinese, Japanese, or something else translation, then that's the machine translation. Or the most lucrative form of the supervised learning today is probably used in. Sorry, somebody's mic is on. Do you want to say something? Okay. So nearly all the large online ad platforms have the learning algorithm that inputs some information about an ad and some information about you, and then tries to figure out if you click on that ad or not, because by showing you ads, they are just slightly more likely to click on. For these large online platforms, every click is a revenue. This actually drives a lot of revenue for these companies. If you want to build a self-driving car, the learning algorithm would be as an input, an image, and some information from other sensors such as radar or other things, and then try to output the position of, say, other cars, so that your self-driving car can safely drive around the other cars. So let me check. Does anyone have any issue? Okay. So no comments till now. Okay. So let's move on. Uh, so this is the second major type of the supervised learning algorithm called classification. Let's take an example, breast cancer detection as an example of a classification problem. Say you are building a machine learning system so that the doctors can have a diagnostic tool to detect the breast cancer. This is important because early detection could potentially save a patient's life. Using a patient's medical record, your machine learning system tries to figure out if a tumor that is a lump is malignant, meaning cancerous or dangerous, or if the tumor that is lump is benign, meaning that is just isn't cancerous, isn't like that dangerous. So I'm sorry. So suppose if we want to find out the person of this age and of the person of size this tumor have the breast cancer or not. So what we'll do is just a second. So what we'll do is a model will bifurcate them. A model will bifurcate them into two parts: benign and malignant, and then it will try to locate where a criteria fits. Like in this example, it's benign, so the patient may not have the cancer. Okay, let me clear just a second. Let's move forward. Let me this box. Okay, so here comes what are you guys all waiting for? Linear regression. Okay, so let us understand the linear regression model with an example. To train the model uh, of a linear regression, you need to find just a second. Okay, Are you guys facing any issue? Like I don't see any comments. Is everything fine with you guys? Just comment. Okay, Aisha is good. Sham is fine. Okay, 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 fine, fine. Okay. So what does this linear regression model does is it creates a straight line. It creates a straight line out of our data set, that is this cross, this represents other real-time data sets. So suppose if you want to find a house with around size of 2200 square feet. So we'll draw the straight line from here to our regression model, and then we'll try to predict the price. So it could be around 2000. Uh, $280,000. So this is what does linear regression does, and so as I told earlier, the supervised learning model has data as the right answers, and it gives us an unknown output. And another type of supervised learning is the classification model that we saw earlier as in breast cancer detection. So it predicts the categories as we saw for that patient, which was right here. So let's move forward. Uh, yeah. So uh, just a second, what happened? Just a second, I'm sorry about that. Let me present once again. Yeah. So to train the model, you feed the training set both the input feature and the output target to your learning algorithm. I'm sorry. Yeah. Uh, then your supervised learning algorithm will produce some function. We'll write the function as a lowercase f, where f stands for function. Historically, this function used to be called as hypothesis, but I'm going to call this function as f. The job with f is to take the new input x and output and eliminate or a prediction, which I'm going to call y hat, and it's written like the variable y with a little hat symbol on the top. In machine learning, the convention is that y hat is estimated or the prediction of the y. The function f is called the model x, uh, is called the input or the input feature, and the output of the model is called prediction, that is y hat, as I told earlier. The model prediction is estimated value y, the target, which the actual true value in the training set. We are going to take a look at some plots of f on the chart. So maybe you are already familiar with the drawing lines on the charts, but even if is a review for you, I hope this will help you build intuition on what w and b parameters determine f. When w is equals to 0 and b is equals to 1.5, then it will look like this horizontal line. In this case, uh, the function of f of x is 0 times x. That is, you can see it here, 0 times x plus 1.5. So if f is always constant value, it always predicts the 1.5 as the estimated value for y. Y hat is always equals to b here, because w is 0 here. So called the y-intercept, because that's where it processes the vertical axis or the x-axis of the graph. On another graph, let's take an example b. B is equals to 0 and w is equals to 0.5. So when w is equals to 0.5 and b is equals to 0, so it doesn't have any y-intercept. So it will start from 0 only, because when we put the value of x as 0, it will give us the point here. And in the third example, f of x is equals to 0.5x plus 1. So this would be our equation if we give w is equals to 0.5 and b is equals to 1. Uh, so it will start from 1 as a y-intercept, because of the bias factor b. So it's okay, guys, if you don't understand this point, because it's all mathematical part. And at the end of the session, I will tell you about the Brahmastra. You can say it, as it will help you in a real world. So cost function intuition. And now let us build some intuition about what the cost function is really doing. We'll walk through one example to see how the cost function can be used to find the best parameters for your model. You want to fit a straight line to the training data, so you have this model as f of w. B of x is w times x plus b. So you can recognize this as a linear equation in one variable. Here, the model parameters are w and b. Now, depending on the values chosen for these parameters, you get different straight lines like this. You want to find values for w and b so that the straight line fits the training data well. To measure how well the choice of w and b fits the training data, you have the cost function j. Uh, what the cost function j does, it means uh, it measures the difference between the model's prediction uh, between the model's prediction and the actual value of y. What you will see later is that linear regression would try to find values for w and b, then make of a j of w be as small as possible. So let's move to the next slide. Okay, gradient descent. With a gradient descent algorithm, what you're doing to do is you'll keep on changing the parameters of w and b with every bit of time. Try to reduce the cost of w and b, right? So we have to reduce this cost of w and b uh, until j settles at or near a minimum. This is the type of cost function you might get if you're training a neural network model. Notice the notice the axis that just a second, where in my, I'm sorry about that. Yeah. So notice the axis that is w. So here should be w and b at the bottom. Okay, let me write it here. W and B at the bottom. So I forgot to write there. Yeah. Yeah. Now let us imagine that this is the surface plot. Okay. So you are actually a view of slight hilly door on the park or a golf course where the high points are hilly and the low points are valley. Like so, I did like to imagine if you will that you are physically standing on this point of the hill. Okay, if it helps you to relax, imagine that there's a lot of really nice green grass and butterflies and flowers. Is really nice hill like this. Your goal is to start up here and get the bottom of one of these valleys as efficiently as possible. With gradient descent algorithm does is you're going to spin around 360-degree from here and look around and ask yourself, if I were to take a tiny baby steps in one direction, let's suppose this, and I want to go downhill as quickly as possible to one of these valleys, what direction do I choose to take as a baby step? So if you want to walk down this hill as efficiently as possible, it turns out that if you're standing at this point in the hill and you look around, you will notice the best direction to take the baby step downhill is this, this. Like you will go like this till you reach here, and then again, if then again we'll adjust the parameters of W and B, and again we'll look 360 here, and if we see some uh, bottom again, let's see, I'm seeing this bottom again, so I'll try to reach there as quickly as possible. So I'll take this path maybe. So it will then compare both the parameters and then it will choose accordingly. So okay, it's the last slide of the gradient descent algorithm. So let us talk about this equation. W is a slope, you can say that, and alpha, what is here, is the learning rate. It will change every time. Like these both are the learning rates. It will change every time. We'll iterate our model, and this is called the derivative. This is called the derivative. We can say that. Oh, sorry. I'm sorry. I'm sorry. Okay, I was just meant to clear this. Okay. So so let's check out the correct way to update our weights. We'll take the temp value of W, which will store this complex function, and temp value of B accordingly. We'll run it in a for loop. Okay, let me check some comments if there's any. Okay. Uh, so if it will run in a for loop, so it will iteratively update the weights of W and B. And let's check out the incorrect way also. If we try to uh, store the weight of W in temp W, and then in W, so it will iteratively add the value here, which won't run our model properly. So let's move to the code. Okay. So guys, just a second. Okay, so guys, hello. So it's the code part. I need you to follow me. Open a fresh tab. Yes, I'll definitely provide the notes after the session. Did you guys open the fresh tab in your laptop? Just comment down. Okay, okay. So like we did yesterday, we need to type collab. Okay. Then click the first link here. It's okay. It was just a theory part. Let's focus on the coding part. So, Kabwe, are you on this screen? Is my screen visible? Okay. So, are you here? Let's go to the GitHub section and make sure that you this box is okay. Then yesterday you forked the repository of Atharva Malode. So go to that repository and you will find the machine learning bootcamp. Did you guys find the machine learning bootcamp? Okay, machine learning. Okay, there you will see week 1 day 2 linear regression model. Just click on that link. So are you guys with me? Are you guys following me? So guys, this would be a complex code because we need to implement these complex mathematical functions into a collab. So after this, I'll give you the Brahmastra as I told you. I'll tell you about the linear regression, that is pre-trained model we will use, and this won't require this much of a coding. It's just for your own understanding. I cannot see week 1 day 2. Uh, okay, Chaitanya has left you a message. Shri, please follow that. Okay, okay, I'm waiting. I'm waiting. Trying to run collab. Okay. Shri, did you got it? Uh, please give me a minute. Okay, fine. It's okay. I'm opening GitHub. Okay, good. Till then, others also comment. Are you guys following me? Did you open the collab? Yes. Okay. Good, Anuja. Okay. Nice, Vishwas. So Shri, is the option visible? Nothing, Weber. We were just waiting for other my friends to. Shri, if it's not visible, then go to the GitHub of Atharva Malode, and there will be an option sync fork in the machine learning bootcamp. Okay, just let me show. Okay, so are you guys seeing? Okay, so she got it. So, so should we proceed to the code? Comment, guys. Yes, I just synchronized. Which one do we click in collab? There will be a machine learning bootcamp week. Just a second, and okay, just I'm showing you machine learning bootcamp, and then sync for if you will do sync fork, you will see the option here week 1 and then day 2. After opening the collab, let me open collab once again. After clicking this collab, we'll open it with GitHub. Okay, let me authorize once again. So you will see option in case I have it already forked, so it's showing me this. In your case, you will have the repository of Atharva Malode and go to machine learning bootcamp, where you will find this week 1 day 2 linear regression. Are you following Kabbe? I'm sorry about that. Okay, okay. So everyone can see the screen I'm watching. Please comment. Okay. So I'm proceeding with the code. So what does this code does? Pip install ipympl is it is used to plot the 3D graphs. We are gonna plot 3D graphs in here. Week 1 day 2 file doesn't show on my GitHub page. Week 1 day 2 file. Did you sync? Here's the option available like sync fork. So you need to sync. I've already seen, so it's showing nothing for me. So I'm proceeding with the code. This is used to plot the 3D graphs. So we need to install. After coming to this, we need to connect first. Yes, I got it. Okay, nice. Good speed. It will show us connecting. Okay, so we are connected. So we'll click the run cell option as and run anyway. So this is all its requirements which are already required. Then we need to clone the library that because it had some files which we will need for our uh, for 3D plotting. So it will take some time. Okay, and then this comment exclamation CP and this link, it will download the plots library that we have created, like on it. So it will copy the plot.py file which contains some helpful functions already written by our team. So okay, you can see that plots.py function here. Yeah, okay, good. So now that you have seen folks Sujal, so open the collab file just like I did, like go to here collab and then GitHub. Okay. So yesterday, my friend Athava told you about NumPy and Pandas library. So we won't look more into the libraries. You can check that on their official page. So what OS does, it provides us some data manipulation tools which would help for our operating system, and then the math library, of course, which we will need to uh, plot this complex mathematical functions, and matplotlib, and this would be helpful for our 3D plotting again, just like this. Okay. So from our plot library, we would want to import this plot regression lines, visualize data, plot real cost function, Supol 3D. Uh, these are all 3D plotting functions which we already implemented on our plots library. So now we need to, okay, I need to run this cell. It will download all the necessary stuff. Okay. So what this cell does is it will generate the random data set. We don't need to import take data set from Kaggle or anything like that. We'll generate our own data set. Okay. So so it will generate the random numbers till 100, from 0 to 100. And what this function does is, okay, then we'll set the initial parameters of W and B as 0, W and B as 0, which always required. For me, I'm getting module not found error. Did you went to GitHub and Shri? Did you sync for? Yes, okay. Did you connect your collab file and your GitHub? It would be better if you like send the screenshot in our WhatsApp group. Okay, 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 okay. Uh, okay, you can follow the Chaitanya's instruction. So we'll move forward. It's okay, Shri. I don't know. I don't- Okay. So this learning rate we saw that was alpha. Just a second. Yeah, this is the learning rate alpha. If you guys able to see this, as I told you earlier, we'd set it to 0.01, not too big and not too small, as it would affect our model's accuracy, and we will iterate it 10,000 times. Okay. So so this is where our complex part starts. We need to compute the cost. This is a formula. I just put it here for reference. Yeah. We'll define a function called compute cost, which would have parameters x, y, w, and b. Okay. Uh, I've commented here the things in case you will need it later when you will want to revise the things. So M would be our this what this does is it would assign us the training examples, like from where we generated the random data set. So as our function says, the compute cost, initially we'll set the cost at 0, and then we'll iterate it over time. Okay. So guys, are you following? Comment please. Hello guys. Yeah. Okay. 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 Yes, we are following. Okay. So let's run this cell. Oh, I'm sorry. I'm sorry. We need to change the values of none here. Okay. So uh, we need to run the for loop. So why we need to run the for loop here? Because of this summation sign, as it will iteratively add the numbers. So in case of none, just write here M, because it will run through our training examples iteratively. Okay. Did you guys write here M instead of none? Let me specify it. Okay. So Shri, has your problem solved? Okay. Guys, comment. Are you guys following? You changed none to M, but I'm following few next steps. Acha, did you already change the none values, Shri? So as we are iteratively using our function, so we need the cost sum like this. Just a second. Cost sum. Okay. It will iteratively add values to our cost sum value, and then we'll write here 2 into m. So why we wrote here 2 into m? Because of this part. As this is a complex formula, we broke it down into little parts. So the total cost here would be 1 upon 2. You can see here 1 upon 2m, 1 upon 2m into cost sum. Into cost sum we already calculated here. Okay. So the cost sum is this. This change to m. Okay. So please change the other values too. Okay, I'll just write here for you guys. Change none to cost sum. Okay. Can't say what comes after 2. There's nothing after 2 here. Are you talking about this? Are you talking about this too? Or this too? Okay, I'll update here. Change none to 2 into m. You can refer the refer this. We are just creating replicating the formula of j of wb in the form of codes. Okay, is it fine now? You can see. Oh, okay, okay, nice. Okay, so I did told you about so everyone followed this. Did you guys change these values that I told you to change? Comment yes, please. Okay, okay, nice, good. Okay, okay. So I told you that we did plotting 3D plots. So when you so just click here at code. and write this. Okay, just let me run this once again as we did changes. Ah, okay, the changes have been saved. Uh, Pause function x comma y comma compute cost. So just a second. Values of x and okay, I'm sorry about that. We use the capital values, so it's case sensitive. So be careful, guys. Fine. Okay, I didn't run this code. I'm sorry. I need to run it again. I need to run every code again. Yeah. So now it will run. Did you guys wrote this? You can play with the values of w and b here. So you can see the little changes over here, as these are parameters w and biased. So it will change accordingly. Yeah, you can press shift enter, or you can go here and run cell option. Yeah, good. Graph is made. Good. So afterwards you can play with this. Like this, we'll do like this. It will change the position of this dot. So I'll tell you another. Okay. So let's plot one more code. Can we have what you include in the code? Uh, okay, just a second. You can see it here. Yeah, here it is. I wrote this code. Just scroll up. Okay. Just run this code and make sure you run all the codes, as I did get error because I didn't run this code. So is it fine? Did everyone wrote this code? It is used for 3D plotting. You will see the figures or graphs, something like that. Wait, okay, fine. We'll wait for a little time. Yeah, it's fine. It's fine. Maybe you guys can have spelling mistake here, which sometimes the coders do. So you can just go here and you can copy this. You can press Control C and Control V, and then apply these parameters and make sure that X and Y should be capital. Yeah, okay, here Chaitanya did post the code here. You can just copy paste it. So you can copy the code from here. Till then, I'll tell you another one of the code. Supol 3D. Okay, then press Shift Enter. Then you will see one amazing, beautiful 3D graph. It consists of parameter W, B, and here the function of J, that is cost function. Mine is giving an error. Just copy paste this Chaitanya had given the code. Maybe you did error in just a minor spelling mistake or X capital. You didn't make capital X and Y. Did you got it? Can you just scroll up? Okay. For this code, Shivam, Shyam, I sent a screenshot on WhatsApp. Okay. WhatsApp. Yeah. Mm, I'll paste the code here also. Yeah. You can just copy paste that code. I just sent you in chat. So should you guys want one more 3D plot? Can you guys comment? Should I tell you one more 3D graph? Okay, good. Okay. Uh, just follow me. Here. Yeah, I'll run this. Just run this code. It will have certain parameters that you will need to adjust. You can just play with the parameters and you will see this dot moving. Takes time. Okay. Just copy the one here and it still gives me the same error. What is the error? Can you please comment here? I'll again paste this code. Uh, okay. Sent it on WhatsApp. Okay, fine. And then I'll play with these. Wait, did you do it? Did you get the output? Okay. Guys, can you comment? Okay, Kunal said done. Good. Can anyone comment, please? Are you guys following? Okay, good. So enough of 3D. I'll tell you one of the 2D graph. Okay. So this is one of the 2D graph that it's just the impression of this 3D graph in 2D form, where again you can play with these parameters to see this red dot change. Wait, let me copy this code and give it to you. Done. Wait, are you following me? Hello, guys. It's okay if you don't get any of this. I'll tell you the most simpler way at the end. So let's move towards another function. We need to compute the gradient. Okay. So again, this complex mathematical formula. Ooh. So again, we'll use the training examples, and what you guys see here, dj dj upon db is that this. It's so we'll initialize it to 0. It's the partial derivative of w with partial derivative of j with respect to w. Uh, so okay guys, I'm tired of this coding, so we'll quickly move forward. I'll tell you. Uh, just change here. I'll comment. M. Are you guys following the way? Hello guys, please comment. Are you guys following? Okay. We'll again make changes here. So instead of none, we'll need to write, let me check, okay, f of, what was this? F of WB. So where is the formula for f of WB? Let me check. Okay, so f of WB is equals to W of xi plus b. So let me try to put it here. Where are we? Yeah, here we are. Uh, where were we? Okay. We're trying to fix the previous one. The characters are small. Please increase. Okay. Is it fine? So we were here. Somewhere here. Okay. So we were here. So what this partial derivative of j with respect to w means? Let me check. Partial derivative of j w means. So we have given the value of here xi. So we need to code this part. Not this. Yeah. Okay. This. We need to code it here. So how will you guys do it? Let me tell you. F of WB minus, let me check, f of WB minus y now, minus y of I into x. Yeah. So this coding part is this one, this complex formula. Okay, are you following? Guys, comment please. Let's wind up this quickly. Okay. So, DJ. Yes, but I'm a bit behind. Okay. Where you are? Little difficult. Yeah, it's fine if it's difficult. I'll tell you a simpler form of this, and I'll even share my collab with you guys. You can carry all the sake of others. Okay, good. Little difficult. Sri, are you following? Others, please respond. And we did here. Huh? F of WB minus y of I. Yes, following. Okay. Yes, not really. Sorry, trying my best. It's okay. It's okay. Kunal, which part you need? Just a second. Let me complete this one first. Yeah. W d of w I. So here, so I'll just write like this is equals to dj underscore dw underscore I. In this made after m. Okay, after this m, you guys need to change the none values and you need to type like 9. Okay, okay. Should I copy this whole for loop for you guys and paste it in the chat box? Please comment if it would be difficult for you to keep pacing. Yes, please. Okay. So from here only, okay, I'll paste it. Just make sure that your indentation is right. Otherwise, you will get multiple errors. Your indentation should be right. Okay. I know this code must be difficult because it's such a complex function, but we'll use some pre-trained models. Okay, nice, good. You can refer this code that I've just sent you. So we'll move to our last function, gradient descent, and then we'll use the pre-trained model. It's so complex code. Okay. So did you guys reach gradient descent? Okay, just let me run and then run it. You guys reached? Make sure you run your compute gradient, otherwise it will give errors. Are all x and y are capitals? Yeah, yes, they are capitals as they are our data set. Just let me show you. They are our data sets, so they must be capital. Python is case sensitive, so that's why we need to make sure that they are capital. So wherever we please increase the, yeah, I was just wanted to scroll, that's why. So we were here at gradient descent. Okay. So now we make the we need to make this formula. Okay. It consists of learning rate and our derivative, of course. What happened? Let me increase the size. Yeah. So again, we'll initialize this empty arrays, J history and P history, which will the J history will store our cost function, the values which we retrieve from the cost function. Just a second. Yeah, it's here. So it appends the values of the cost function, and p history stores the value of our parameters. Okay, is the character, yeah. Okay. So again we need to run the for loop, as it will iteratively iterate a model. So we need to change this none. So what could here be? Let me check the formula. B is equals to B is equals to B minus. Okay, B is equals to B minus alpha. uh, B minus alpha. Okay, B alpha. Here we need to change none equal alpha. So why we wrote instead of this, you can make it easy by typing is equals to b minus alpha into derivative of j with respect to b. That is b is equals to b minus alpha into derivative of j with respect to b. This is where this code lies. So again, I'll type it unequals alpha and just run. We just have to change the two values here. So I'll copy them. Just make sure the indentation is right. Are you guys following? Hello, just comment guys please. Okay, error, printf iteration. Let me check the error. What is unsupported format? String passes to tuple format. Did I run the last cell? Okay, let me check earlier cell. Print. Is there any none value? Okay. Unsupported format string pass. I'm sorry guys, just a second. I'm sorry. So I'll tell you about the Brahmastra earlier. So I'll tell you about the pre-trained model that has been used by scikit-learn. So just type with me. Thank you, Weber, for telling me from scikit model is equals to linear regression. We'll store our linear regression model in the model and we'll assign the values of x and y is equals to data and y is equals to data. Did you guys wrote this? Uh, okay, so it says data is not defined, so we'll just define the data. Import pandas as PD and we'll define the data is equals to PD dot data frame x is to x. X will assign the values of x and y as, and to check whether our data has been stored in x and y variable, so we'll just run data. Okay, data, I'm sorry. Yeah. Okay, so we have 100 rows and 2 columns that are stored in variables x and y. So we'll try to fit the model according to our variables. Model dot fit x comma y. We'll try to run. We'll show that means our linear regression model has been implemented. So we'll just print our slope and bias factor. Okay, so slope w is equals to model dot f score 0. train to intercept B the model dot intercept. Okay, just a second. Let me put this code into the chat box. And write the data. You can just copy and paste. You can do this in a completely new collab. It doesn't relate it to other above. So now we'll plot our linear regression. Model. So here we are done. So now that our model has been trained, we'll check if the model is right or wrong. So we'll x test equals np dot array. We'll give them the value of 0.8. Okay, one over here. It's the 0.8 is just a sample value to predict a y hat. So y test now we just print statement here to predict a y, that is y test 0. Y test is not defined. Okay, about the underscore. So our model is working, guys. From here you can paste the complete code into new collab. It doesn't matter. So I would like to end here. Okay, I would like to hand over the mic to Atharva Malode.
Hello everyone. Am I clearly audible? Let me know in the chat box. Guys, quick. Just waiting for you all. Okay, I can see it's resound. Okay, no. Is it sounding once again now, or is my voice much more clear now? Yes, I'm just checking the chat box. Okay, ready to go. Great. No need to worry, guys. So, guys, how was today's session? Can I just know? Have you all guys heard regarding linear regression before? I think you completely implemented the linear regression portion, right? That to define by defining your own functions, mathematical functions. Yeah, someone is saying cool. Difficult for me. Okay. Okay, Shri, I know it was quite difficult because we have dealt with lot many mathematical functions there, right? But let me know if my screen is visible. Great. Okay, somebody did it in his first sim, right? So the thing we did above this line, which was above sklearn, that was completely from scratch. So this must be the code which is working behind sklearn, right? Okay, you are going to learn it again through the recording later, right? So can I just know what is gradient descent in the chat box? Guys, gradient descent was really important one. Okay, I will learn again. Great. So no need to worry, you will get the complete recording. You can go through it once. So we'll just have a quick recap of the collab file we created, and then we will download the collab file and upload it on GitHub, right? The thing which we have to do from starting. I think key much of many of you have found it a little much difficult to understand the thing stuff, right? Okay, no need to worry regarding this. Go through it once again, right? So we will have a quick recap. So guys, can anybody tell me what is linear regression? Anybody in the chat box? Okay, let's see that with a graph. I guess we visualized a graph here. Okay, machine learning model. What type of problem it solves? Anybody? The name itself says. Linear regression, right? So it is solving regression problem. So guys, we will just have a small look over the sklearn model we imported from sklearn. So what is sklearn? Can anybody tell me? So actually sklearn is a library which we have, and it has already pre-trained model. So you have to just pull the model from that library. If you want to learn more regarding sklearn, so just go on Google, open a new tab and just search for sklearn. It will work most probably, I guess. I hope my screen is completely visible to you all, or I guess Danish is saying that, right? So sklearn, which is also known as scikit-learn. So this is the official website of scikit-learn, and whenever you move towards classification regression here, like for example, we saw regression, right? So let's open the regression, and whenever you open this regression, you can see completely pre-trained models available. You just have to import this. You can see stochastic gradient descent. I guess most of you guys have learned regarding gradient descent. Anybody? What is gradient descent? I guess you implemented that in a sort of a function in the collab file. It's an algorithm. Anybody else? Optimization algo. So can anyone just give me a small briefing regarding what was it? What was gradient descent doing? How was it working? How was it finding the parameters? Depth descent. Yeah, I guess somebody is much more near. Help to minimize the cost function. Okay, great. I guess Janvi got it correct. Minimum of differential. Do you want to say function? Because I guess f is not printed. By minimizing the error. Yeah, I guess Janvi is the one who has benefited the most from the entire session, I guess. So guys, basically gradient descent is a step descent function. So what gradient descent did was it just optimized our algorithm. Right. So how gradient descent work? Can we have a small overlook over that if you want? Like, let's see the slide. This was gradient descent. And okay. So I hope the screen is completely visible. So just imagine that you are on the top and you have your output in the deep. So what will you do? You will just move towards the deepest part in the mountains. Similarly, gradient descent work. It tries to move downwards and learn that what our expected value should be. it helps to achieve the global optimal solution, right? So what is the global optimal solution, Janvi? And how can we get that? Just hit the chat box. I know it was quite difficult because we dealt with lot many mathematical functions, but no need to worry. After this, you are not going to deal a lot with that. You are going to handle it, but not a lot. By manipulating the parameters. Yeah, it is. You are somewhere right. Okay, Jarvis saying it's kind of a help to find the lowest value to have the best fitted regression model. Great. So I think you all guys got the best from the session. It seems that because I can see few answers coming out there. And those who still find it difficult, so guys, you can just do a thing. You can just rewatch the entire session and just get the things, or else you can also open the sklearn library. In sklearn library, you can see all the pre-trained models which are available and how they are being implemented, not with the code, but with the theoretical portion. You can go through that once. These are all the linear models available. I guess you used one, right? You can also see, guys, here a gradient descent. So you can just open that. So okay, it is moving a little tougher side, that is perceptrons, but just you move down, you will see the explanation for that. So you can you all guys can just read it once and try to expand your knowledge. And definitely you are going to look over the entire linear regression in the recorded session, I guess, because it was quite difficult for a few folks. Right. So that's all. Thank you guys. Let's finish it here. Let's meet on the next Saturday where we are going to see logistic regression. No need to worry regarding the stuff. That is going to be amazing session. And you are going to learn many more things. Right? Can I just see a high five in the chat box? Okay. Increase the font. No need to worry. Cafe, is it visible now? Okay, Vaibhav. Great. Okay, just have a small look that how we are going to submit the file. So this is your linear regression model, right? Maybe possible that you created a one more collab to learn or whatever it was. Just go to files, and after that files, just download that. Where is the download option? I can see that. Okay, I'm able to see that. Download this IPNB file. Once you downloaded it, is it available? Yeah, it is available in the. Okay, now just go to a fresh tab, and on that fresh tab, just hit GitHub. I guess, okay, that is did it for us. So now GitHub repo is open. Just open ML Bootcamp. I guess, guys, you all must be having this repo because we forked it, right? Each and every one of you forked it. We can see 81 forks. This means 81 guys are there working over it, right? Now what you have to do is just open week one. That week one, you have to open day two. And okay, we can't see any submission folder. I guess one of our folks just missed it out. So let's do that stuff. Just see this magic, guys. If you just write github.dev here instead of .com and just hit enter, it will open the VS Code editor, right? Maybe it is possible that it is for first time, so it may take a little time, but I guess it has opened, right? So you can see the complete VS Code in front of you, right? Is it visible? Okay, I guess it is visible. Just let me know if it is visible. Okay, great, Janvi. So what we have to do is we forgot to create the submission folder that was from our team side. So no need to worry, just move into day two and just write submission. Was that right? Submission. Guys, you don't have to follow this step. It's for me, right? So no need to worry regarding that. Don't follow that step. Please don't follow that. So just have a new file. I'm just telling you guys so that you can learn new stuff. We created a file. We created a folder in day two, right? Now what we are going to do is we will just tap here on the fork. We'll just write the message. So it is from organizer side. So organizing team, right? So just write organizing team and just give two semicolons. And now just write that added, what you added? Submission folder, right? So write the commit messages appropriately always, right? Why? Because your teammates are going to see that, I'm going to see that, so I should know that what exactly you changed by just seeing the commit message. I guess it is committed and pushed. So just wait for a second. Okay. No, we don't need that. We'll try it afterwards, right? I guess it's done. So now what we will do, instead of github.dev, just go here back and just hit github.com and just hit enter. Great. I guess. Okay, guys, great. The folder is available. Let's check it once, right? So I just opened my folder ML Bootcamp, and inside that ML Bootcamp, I just moved to week 2. No, it's not week 2. Can I just know from you all? Is it week 2 or week 1? Okay, so we are just opening week 1, then we are going to day 2. Once we move to day 2, we can see submission folder here, right? Is it visible? Week 1, right, Vaibhav? Is it visible? That is submission folder. Yeah, week 1, day 2, great. So just open the submission folder. Now, from here, our step starts, right? So you all guys can follow me if submission folder is available. If it is not available, it will be available in 5 to 10 minutes. No need to worry regarding that. Fine. Once I pushed a pull request. So just see here what I'm doing. Just go here and okay. Okay, I can see add file here. So go here, upload file, and inside upload file, what was the file? Can anybody just tell me what was its name? Its name was linear regression, right? So just hit that and just open that. And can you see it on screen? Is it done? I guess it's done. Okay, it's uploading here. Right. Great, guys. It has been uploaded here. Right. So you all guys can also rename it. And it would be preferred if you rename that. Like instead of linear regression, you can rename it with your own name. So it would be good if you did that because it would help me out a lot. Or else what you can do is just go here and after going here, create new file and let's name that file as a folder with your name. Like my name is Danish. No, that is just right up above, right? So he's writing. So it's okay. It's not visible. It's loading. I guess there is some glitch or screen is freezed out. Okay, great. So it's done. So what we have to do is we have to just name your file. The name of the file should be with my name. That is writing it right, I guess. So spelling is also right. So great. So just commit these changes. So a new folder will come into picture. Like this folder is here now. So this folder will come into picture. Once this folder is come into picture, just commit that message. Once you committed that, okay. Are we doing something wrong? Let's try to figure it out. So let's open the download portion. Give me a second, guys. It seems that that is facing some issue. No need to worry regarding that stuff. We were there to upload a complete folder with our own name, right? So this was his linear regression model, I guess. So what we will do is, so what our work was just to create a new folder on our own desktop, name it with our own name. Now he's doing it right. So just name it with my own name and just drag and drop this file inside that. Like I will just, what I will do, I will just cut it. I will just paste it out here. Once I did that, now my folder is ready. I guess it's ready. So what you have to do is just open the Bootcamp folder and inside the Bootcamp folder, go to upload files. Once you go to upload files, you can see choose your file. Once you saw choose your file, go to down where it was. Can anyone just tell me? Yeah, this is the folder. Select this folder, select the open. Okay, so just write here submission and just write what's your name and just commit the changes. I guess it's done. Now I can see your submission within little much of time because someone is needed to accept the pull request. So it says to commit side, right? So just click on this two commits and just create a pull request And what is the title of your pull request? So submitted a file will work. Submitted a file, or just write once more the commit message we did so that you all will not get confused. So submission, spelling of submission is right? No, just help me out. What is the spelling? I guess I wrote it right now. So just give the name and you're good to go, isn't it? I guess you're good to go. So just create the pull request and it's done. Now Athar is able to see that. Great. So we saw the steps which we did yesterday, and that's all. I guess we can close. Hope you all guys enjoyed a little. A little. I'm just saying a little. Right? So that's all, guys. Thank you from my side. We will meet next Saturday.